Hi, my name is Jaroslav. I work in Talsec as a Flutter developer for I believe it's 5 years. And today I came here to talk about security in Flutter. Uh, we all know, or the most of the talks you probably see, it's about Flutter being amazing, how you can ship things fast, how you can do everything very easily, how you can put together application, you can put it on iOS, on Android, on macOS, whatever, and it's everything fine. The problem is, as always, that security comes in better case as at last, in worst case, not at all, because security is this kind of annoying thing to do, right? We have this and this, and we have this, and we had all this data, and right now we have also this regulation, and we need to fill it. So what to do now? And we are shipping for Flutter, right? And this is the thing where a lot of people just don't care. We can especially see it nowadays when we see a lot of those, little apps or SDKs or services, especially built with AI. People will just throw something, they will get some generated slop, that they will put it on the internet, and then we see a lot of things, especially on Twitter, when people are complaining yeah, I have this and this service, and they attacked me, and why is that? Oh, I have my API leaked. Yeah. Tough luck, buddy. So when you have things like Flutter, which is easy to build, and especially for AI easy to build, I've seen a lot of people choosing Flutter just because you just put AI on it and AI can work with it very well, then they will just build it, ship it, and then they are complaining. And a lot of these people just come back and they're complaining yeah, but I thought it's native, right? When you look at Flutter and Dart, it's both is compiling into native code. We will see that. And they're okay, it's native. I thought it's going to be easy. But the problem is, no matter what framework will you use, no matter what platform will you ship, you will still need to care about security. Problem with when we're talking about security, it's a very abstract topic, right? Yeah, I'm going to talk about, yeah, we have this issue, this issue, this issue, but it feels very, very distant. It never happened to me, so why should I care, right? But when you look at the numbers, it's very, very real. It's not just somewhere, some guy talking and trying to be very smart. It's a thing that's happening, especially if you have some application which is part of some critical infrastructure, or when you do something like banking. Especially, I've noticed a lot of bank applications, especially from India, and they love to use the Flutter, and when they do banking in that, and then I see this, I'm kind of scared. This graph, it's supposed to not to just, just to scare you, yeah, a lot of root, a lot of jailbreak and stuff happening. It's supposed to show that no matter where you ship, the issues are still there. You can still see some root happening, some jailbreak happening, and you can see happening it during the time, right? It's not just one thing, it's constantly happening. We even did, we even did the whole report where we broke the data down based on the whole world, on continent. You can grab it on our on a booth after the talk. And we just clearly see the pattern everywhere. So those threats are not theoretical, they are practical. They're happening. So where does those threats come from? Where do they appear? In general, we can divide those two, those threats, which happens like inside the app or on the user device. You can, against these, you basically have to just try to be a good developer and try to avoid these. Against these, you can't do really much. Like what you only can do is protection. You can do much prevention, but you can do active protection. So first, we will talk about those static threats or static threats, which are these which are occurring inside the device. Or more likely, I would like to call it like, or to describe it as what can attacker or potential attacker learn before he can even run the app. So the first thing, the basic one, it's missing obfuscation. It sounds hilarious because like you'd think in 2026 like this would be covered, but this is still a thing. To basically describe obfuscation, it's basically making the code less readable. So the attacker who's trying to decompile the stuff has a harder time to make it make sense. The problem is nowadays with AI, it's maybe a bit less significant, but it's still a very good thing to have. So maybe enough talking and more doing. Right now, I've prepared a little demo. So yeah, live demo is a very good idea, I know. It's like trying to humiliate yourself in real life. It's amazing. 10 out of 10, I recommend. Yeah, you see good, okay. So right now I prepared a bit of demo. It's nothing really fancy, it's something that the AI would make in like one prompt, right? The basic point of this is, I will make a call. And when I will call, it will tell me like, okay, I returned 200. Nothing really special. Like, you literally just make HTTP request. Here, I've pulled out, yep, I've pulled out the APK. Yeah, side note, everything I will demonstrate here, it will be on, or based on Android, because working on Android is A, easy, and B, you can easily replicate it on your own. And because getting APK is simple, you will just run like Flutter build APK and you have APK. But getting IPA is Apple. Never mind. Anyway, here we have APK and APK zip. APK is basically just the format in which Android applications are shipping in. To get some useful data, you can do two things. First thing, if you wanna look like really, like a techie guy, clever guy, you can make APK2, D. You're gonna put it APK, and he's gonna just crunch it. He's gonna be like, yeah, I found this. I decompiled DEX. DEX is special format which Android use. That's actually not important to us. Then you have some manifest, assets, yada, yada, yada. But if you want to be boring sometimes, the thing is that APK is just zip. So you can do just unzip. Wow, magic. Anyway, I will continue with this APK. Yeah. So I will switch to app release, and here we can see, I'm gonna clear that to you and do this. We can see some file structure. Unknown, we don't care. Smiley, that's special format which Android files are decompiling for us, we don't care. Res, we don't care. Original, we don't care. Like the only thing we care about is basically just lib and assets. We will look at assets later. Right now we are looking at lib folder. So I'm gonna clear this, I'm gonna do this. Yeah, we also need to choose the architecture. We are ARM, we love ARM. And here we have two things. We have libup and libflutter. Libflutter is basically, maybe first thing, what is SO? SO is shared object, which is binary format of programs. Basically, if you know like language C, C compiles into many formats. One of them is SO file, shared object. libflutter SO is basically compiled Flutter engine, nothing really special or important. However, it is used when tool reflutter is patching. Basically, it works like it will compile its own libflutter and then it's going to replace it. However, we're not going to do that today. And we have libup SO, where lives our program. Then we have nice utility called strings. Strings basically do, oh, it's not going to work. Strings basically do that it will take bytes and we'll turn them into printable characters. So yeah. So right now what we can do is just strings. Leap up SO. I'm going to grep. And right now I'm going to cheat because I know, or we're going to cheat together, you know. I'm not going to be alone. We know that this function, which makes the call, as you can see, like it's doing some saving tokens, yada, 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 HTTP GET, it's called make secret call. So right now, I'm going to use absolutely plain, boring grep, nothing fancy, really. I'm not going to even finish it. Yeah, stop trolling me. Oh, would you look at that? We have it. We can even make it better by using the very nice thing called yeah, it's the X. Apologies. So I'm gonna do this and this. Oh no, not here. Here. 2x, boom. We even have an offset. Oop, oh, you don't see. Sorry. We even have an offset, which then you can use in, for example, some more better tool like Ghidra, which also takes SO files and it can do way more stuff. And you can use it and you can locate this call there, and you have very good head start. So this is the reason why we always obfuscate. One small side note: Flutter obfuscation doesn't obfuscate strings. I think that's actually the next point I have in my presentation. Yeah, hard-coded secrets. Hard-coded secrets are very nice old classic. Like it's old as internet itself, I would even say. Basically, whatever is in your code is visible. It doesn't matter like if it's in binary or whatever format it is, it's public. So when you put something nice into your code, it can be, whoa. It can be retrieved back. So we can make something like, I don't know, these strings were nice, right? So we can make strings, we can call it again, but we'll call it grep, HTTP. They're probably using S, I would even say nowadays. Nothing special, nothing special. Oh, would you look at that? That looks suspicious. They were tasked that app, and we will see, yeah, tough luck. Anyway, Also, the same thing would be for the header. We have header here with some super mega secret. Maybe I'm gonna, yeah, a little bit. We have this very nice value, which you would also find, but I'm gonna skip it for now. Export assets. This is also very nice because some people have a feeling that when you put assets there and you will refer to them, they will just magically disappear. Well, they won't, of course. Actually, this is so nice that you have literally a folder called assets. And because we are in Flutter, we have to be special, so we have to do Flutter assets. And because you're Flutter, we're special, we need to do assets again. Then we will see this, some ultra secret. Oh, what's that? We're gonna cat it. Mega secret. Very hard. Okay. So if you have something in your assets like, I don't know, some tensor model or whatever that are supposed to be under some heavy protection because of some intelligent knowledge and stuff like that, please don't just throw it into assets. Ideally, it shouldn't be in app at all. In the bear case, it should be at least somehow encrypted. Another funny thing is insecure storage. Applications, I mean, obviously, when they work, they need to store data, right? Like when we are doing some preferences or when we are fetching some data, we have cache, yada, yada, yada. You know the drill. Problem is, what solution will you use to store data? Very popular solution is shared preferences. And not to be rude, but shared preferences are nice. They're nice when you want to save stuff like, would you like kilometers or miles, you know? Would you like to show minutes or hours? But people or developers used to misuse those to save some sensitive content there. Or even better, they're thinking that when they're gonna just hash the content, it's encrypted. Problem is, shared preferences can be viewed kind of easily, and you don't even have to root the device for it. We're gonna look at that later, actually. Then also, people used to save important stuff as a plain files. We see that basically earlier. We see that the assets are visible, or sometimes they're clever. Like, you know what? I'm going to get SQLite. Well, I'm going to use SQLite because everyone uses SQLite. Duh. So they're going to just look up the first tutorial, maybe something that ChatGPT told them, and they're like, yeah, SQLite, maybe I'm going to push some Cypher. And right now, the SQLite is asking like, yeah, can you give me password? Okay. You know what? I'm going to hard code that password because why not, you know? And basically, it's like hiding the key under the doormat, basically. Yeah. The next thing is, I even seen this one, like really, is that people, I mean, this is like rare, but still, deploy into production debug build. I don't know what to say to this, but I mean, for very obvious reasons, you shouldn't do that. Like, right? Like, first things first. When you have application in debug or it's debuggable, the first thing you can do is you can go to you can go here. You can see an explorer, right? So here you can see content of your very nice device. You can go to data, you can go to data. Here you will look for your very nice application, which is like com, example, mdevcamp.eu, shared preferences, and you can read it. Oh, would you look at that? Another token. And why is that? No, well, because it's debuggable. If I want to do something with some other applications, the Android student is gonna complain like, I don't know, I'm gonna pick like, I don't know, vending for example. Yeah, this guy's not debuggable, fuck off. Or, I don't know, let's put this one. Nope, not debuggable, go away. So yeah. Also, um, Flutter, especially in debug, produces very nice thing called kernel blob bin, which contains basically somewhat understandable version of your whole source code, basically, because in debug, it's not ahead of time, it's just in time compilation, if I remember correctly. So, first things, how to cover these. First things first, don't do those, like, obviously, which means obfuscate your stuff, you know, with the flag. Save the symbol files, because obfuscation has very, very bad behavior that it obfuscates stack traces. So when someone's going to complain that something is breaking down and they're going to give you stack trace, you're going to see just a bunch of Chinese tea, basically. It won't make any sense. Next thing is secrets are never safe locally, so keep secrets ideally server-side. Not every time it's possible, I understand, but try to keep them server-side as much as possible. Then, of course, then also treat assets as public, basically readable. Be mindful of data you're storing. If you're storing something like preferences, it's fine to just have shared preferences. If you are storing something more sensitive, please use it server-side or something more appropriate with encryption. Yeah, and check your artifact that you build that is not debuggable. The second group big I want to cover is dynamic threads. Problem with dynamic threads is that it's oftentimes not even like your fault. Like you're not able to do anything in your will to make device not rooted, you know, or make Frida not happening, right? It's just the environment being against you. The first things, the lovely thing we have is rooted or jailbroken devices. For those who doesn't know, root/jailbreak stands for when the user has root rights in the system, which basically breaks every security measurements, because most of the security measurements they are based on permissions and access control. For example, on Android, every process is running under its own UID, for example. Android breaks that because root is king and root can do everything. So when device is rooted, you don't have any security guarantees, basically. You can do whatever. Also, it's very popular to combine root and some malware. Like you download the malware, which will root your device, which will then do more mess. Next thing is hooking. Hooking is basically when you have running code, running instance. Then running app is basically just file, because Unix, right? For Unix, everything is file, almost. So what you can do is hijack the process and inject your own code. This is difference between tampering and hooking is this is happening dynamically, where tampering is basically statically changing code and then pushing. Hooking is happening during runtime, basically. It's very often used more for like toying, you know, like what will break what, and after that, the tampering will go next and they will fix that place permanently. Yeah, and there's the tampering, basically used for the same stuff, basically bypassing the paid features, bypassing, like a lot of times you can see it on Spotify, you have those like cracked versions, you know, like where you don't have to pay anything. Malware bypasses, injecting ads, A lot of times you can also see like attacker will just take your application, inject their own ads, and they will put it into some third-party store, like troll store. Then the general category next is malware. This is kind of self-explanatory. You just have malware basically, which makes a lot of mess. Difference between root and malware is basically, while root doesn't have to be necessarily bad because some users just want more control, malware is made specifically to harm the user. Basically, what you can do to cover dynamic threats is first make assumption that device is never impenetrable. It's never safe. You can just assume like, yeah, I can do this because user is going to be fine. You don't know what the user is running. And ideally is to apply some device checks. This is kind of complicated. I will get into it in more detail in a few slides. But basically, you should check for device status. If device is kind of suspicious, then you should maybe restrict some actions. If you can see that your own application is compromised, then you know that you can do nothing, and you should ideally just terminate the whole application. Because while this might just mean that the user is just more power user, this down here is direct attack on your app. So what we can do in Flutter, basically some built-in prevention, that's static analysis, standard tools like SonarQube, Snake, linters are also nice. Some also support, some stuff like checking for your keys, whether they are not, you're not leaking some keys. Obfuscation, we talked about that. Scanning for secrets, that's sort of related to lints and static analysis. Nowadays, even GitHub, I think, on push, they're checking for keys. Not always. There's obviously sometimes some key will always leak, but it's sort of okay nowadays. Also, dependency reviews to check whether you won't have an issue with dependency. A lot of nowadays we can see a lot of attacks from poison dependency, basically, when someone will hijack the account of some creator of some package, and they will push some poisoned version, and everyone will just download it, especially when they're gonna run pub-get, and especially if they use the carrot syntax. And lastly, following some guidance, I recommend OWASP Master. It's in general, it's boring to read those, I understand, but they have very good knowledge. They can give you a lot of information. Runtime prevention, RASP, we will talk about that. Maybe you can do also some backend check, which basically means protecting not just application, but your backend. If you can't trust your application, you can make it so the issue won't come for your backend as well. And network hardening using pinning. Some people call pinning obsolete. I think it's kind of relevant, especially if you have some dynamic pinning where you can change certificates dynamically and not have to wait for like new release of your application. Testing and verification, some tools you've seen. APK tool for decompiling. JDX does the same. It just has a nicer graphical UI. Strings, we've seen that one. Grep, just basic one. Read elf, basically just to be able to look at SO files. It's kind of complicated a bit. Frida, that's basically for dynamic instrumentation. Magis, that's basically root, because sometimes it's good to play as an attacker. And for guidance, there's OWASP Master, which is a bit different. This one guide tells you how to test and what to test. So right now, we'll move to runtime detection, because I was kind of like, yeah, just do runtime detection, like yada, yada, yada. It's so hard. Yeah, it's very hard, because Problem with runtime attacks, a lot of those detections are kind of, you're just cooking out of water, or you have to do like a lot of heuristics where you can't prove that something is there, but you can see that something is wrong. Like if something looks like duck, it quacks like duck, and it walks like duck, it's probably a duck. So, but you cannot see the duck, that's the problem. So doing this like in-house can be kind of requires like a lot of knowledge, a lot of time, and time is money, obviously. One of those, like I like to call it like universal solution, is runtime applications of protection, which can be basically boiled down as a library which detests risky environments and active manipulation, basically all the stuff that can go wrong, like root, jailbreak, debug application, missing obfuscation, and stuff like that. This is especially useful when you have business which is critical on data. A lot of countries, especially in banking sector, require that even. Yeah, and often implement it as a drop-in library. Time for a little self-promo. Talsec has their own library, basically, Talsec Grasp, which works in this way. Basically, you drop it on device, it detects the stuff, and it works on everything. Basically, it doesn't matter if you have Flutter, Android, native iOS, Kotlin multi-platform, whatever, it works just fine. When some issue is detected, the application reacts, and also the log is being sent to your CM, so you can actually later do some analysis on it. Then next thing which is important is API protection, because you can make assumption that, or we are working with the assumption that device is not impenetrable. And a lot of times you have those guys who don't even care about the app itself. They just want to, get the endpoint and maybe hoard the data out of your endpoint, right? And they can easily pull out the endpoint, and if they're going to use something like burpsy, they can even pull out technically also the token. So what you can do instead is trying to establish trust between the client and the server. And you can establish that trust based on RASP, which we discussed before, which is basically what AppyCrypt does. Basically, you have some RASP checks, which checks for your status of device, and it will take all of those signals, it will smash it into one single piece of data, let's say, called cryptogram. And basically, for every request you have on your endpoint, you will send your request. In header, you will also put the cryptogram, and the endpoint can then verify whether the device, which make a call, that A, he provided some proof that he can be trusted, and B, he will check like what's the security status of the device, and if it's correct, the server will allow the request, otherwise it will deny the request. So even if someone will steal the endpoint, and technically even the token, you still need cryptographic proof that you are the app which is integrated AppyCrypt, and B, that you are safe actually, that you are secure in secure environment. Before this, I would maybe like to show you in action how does it actually look like. I think we can close this one. Yep. Okay. So basically, how can I'm gonna put it into middle. If you won't mind, you won't. There you go. Basically, this is our application we use, our demo, and it has implemented. Yeah, thank you. It has implemented Talsec Grasp, right? you can see that the threads we are, the amount of threads we are covering, like it's a lot. From integrity, which is fighting against tampering, to obfuscation, unofficial store, whether it's running on simulator, whether your device is being jailbroken, whether it's hooking. Right now, he's going to be complaining about developer mode, obviously, because I'm on Android Studio. He's going to complain about ADB because this is using ADB. He should be also complaining about. No, I think that's all. He will complain about screenshot actually right now if I'm going to do. Yeah, he's complaining. Time spoofing, unsecure Wi-Fi, there's a lot of stuff you can check. Some are more relevant, like root and jailbreak and, I don't know, debugger. Some are less relevant, like VPN, even though I've noticed nowadays a lot of people are checking VPN, especially because of geographical location. Also, here we can see also API grid in action, which basically has simple 3 steps. First step is we're going to generate cryptogram. So the screen we've seen before, he's going to take those checks and he's going to put it into this small, I will call it data. he will smash it together into this token, let's say. And right now, when we want to make a request, we will, in the background, he will put this into a header together with the rest of the request. And we can see we have HTTP 200 because you can individually set like what of these are okay, what of these are not okay. We have specially set developer mode and ADB as not care because then we couldn't demo it, right? Because it would be always complaining. We have also block screen caption. This is, by the way, very funny because if I'm going to do this, you're going to see nothing. But I'm going to still see the screen. Yeah. So, to briefly sum up, Flutter is not insecure, not magically secure. Just because it's binary doesn't mean it's impenetrable. No, it's not. It's just binary. It's harder to read. Like that's all. Native compilation is a speed bump, not a wall. The issues which are bothering the native solutions like native Kotlin, native iOS is still the same. So apps can be still inspected, they can be still, device can be still bad, and you still need to defend your app no matter what. Ideally, by doing good practice, and for dynamic threads, when you need a bit of step up, it's very nice to just use some library. And that would be it for me. If you liked it, I'm very glad. If you want to connect, you can. And also, I'm inviting you to demo at 1650 at our booth, where you will see maybe even a bit more than what I showed you here, of more security we can do. Thank you.
Thank you very much, Jarda. Do you have any questions, or do we have any questions at the Slido? You can ask the questions there, or I can give you the mic and you can ask them in person if you want. You can come up here. No? Okay, we have some here. If you have to choose one or two most important, low-effort, free modification to most apps to improve security, what would it be?
So that's kind of hard question because define modification, because there is some minimum standard that should be always, like, for example, like I don't know, like obfuscation nowadays is like necessary. But if I'm gonna take it as low effort, I would say taking some some dynamic library like Rasp, not just us. There's a lot of community around it also on GitHub if you're gonna look. But yeah, we also have like free Rasp, which is for free, obviously. And basically to do that, to add that, problem with that is that it might cause false positives, so you need to be aware of that. And second, I would try to, as I said, I would try to keep away from the device as much data as I can, because, as I said, like anything which is local is kind of, visible.
Thanks. Does attacker can just remove Talsic initialization call? Okay, I don't know how to pronounce it. Sorry.
I expected the question. Yeah, because it's always like yeah, add this and it's gonna be fine. It's gonna be like yeah, but I'm gonna remove that. Yeah. The thing is that obviously we thought about that. Like what we implemented are multiple safety checks, which means that the attacker shouldn't just use initialization call, but he would have to do it around a lot of places. And even if he succeeded, then yeah, congratulations, I guess. You are into application. You have to still deal with AppyCrypt, and you can't do AppyCrypt with broken Talsic.